All right, so let's actually edit our detect construction class, or put it another way, the class which controls the geometry of our simulation. So currently in home directory, so let's just cd to the edepsim, and let's just go back to our build, which already set up. Let's just think we've got it compiled already. Good. So if we just open up our source and detect construction, and just in case for anyone not using MobiXterm, if you wanted to use gedit, you could just go gedit ... for up directory, then slash, then source, then detect construction, and put ampersand at the end to open it. But I'll just be using MobiXterm with Notepad++. So if we look through this detector construction.cc, we see all these included headers. Again, these are the included code to perform certain functionalities. So you see we've got G4 box to make boxes, and logical volume to make logical volumes, and NIST material, NIST manager to make materials using the NIST manager, and etc. So we see a few construction, deconstruction, destructor methods, which don't do anything. But then when we get to the actual construct function, we see the materials. So remember, the general layout of a detect construction file in Geant4 is that it makes some materials, and then from these materials we then make volumes out of these materials and place them in the world. Well, we make a world using materials, but so if we just look what we've got currently, we've just got this one world volume place at the moment. So if we look at how it's defined, it's 1 meter cubed or 100 centimeters cubed. So remember, the order in Geant4 for geometry is we have a solid volume, then from a solid volume, which is just defining a volume in terms of its dimensions, we then make a logical volume, and that applies a material to a solid volume. And then we make a physical volume, which is actually placing the solid volume or the solid shape with a material in our world, or in this case, creating the world. So if we look at the G4 box, and if we look at how what it's taking in this, so this G4 box is a function, and it takes arguments into it. So the first argument is just a string name for this variable that we're calling we're calling world, and the arguments after the string name are just the x, y, z coordinates. And remember, in Geant4, most of the volumes are given in terms of its half volume. So remember, if we think about the volume being placed at an origin at like 0, 0, 0, then what these distances represent is distance from the origin. So in this case, world x divided by 2, it's saying for this G4 box called world, have the x defined as, in this case, it'd be world x divided by 2 from the origin. So it's always the distance from the origin. It's not its total length, it's how far from the origin we want to go. So that's why we have this divided by 2 to get the actual final sizes of 1 meter. And just while we're talking about the G4 box, remember, whenever you see this asterisk, or you might be more used to it being used as for multiplication, remember this isn't saying G4 box times world. What this is saying is G4 box is a variable, and this asterisk represents that this variable called world is being pointed to. So this G4 box with an asterisk just means it's a pointer. So it's not multiplying by the world. It's just saying that this world is a variable which points to memory, which is holding a variable called G4 box. Again, you don't need to worry about this, how pointers work at this stage, but just be aware that we're not multiplying things. This is just to say this is a pointer, and which you can think of just as a type of variable for intensive purposes. So once our solid box is created, we can then create a logical, we can then make a logical volume from it. Again, it's pointer. And so in this case, we've called it logical world. And this, again, is a function. So its first argument is the solid volume we created here. And the next variable is a material type. And in this case, we're assigning it material of air. And we create all these materials just with the NIST manager. And then after the material that we want to assign to the logical volume, we then just give a string name for this particular logical volume. And then again, you don't need to worry about any of these arguments at the end, just give them zeros all the time. Then once we've made our logical volume, we can then make a physical volume. And in this case, we've called it physical world. And this uses function G4 PV placement. And in this case, remember because this physical volume is a world volume, it's a bit different compared to what regular physical volumes would do. In particular, because this is the world, it's the top of the top volume, so all other volumes are placed inside of this world volume. So as such, it hasn't got a mother volume, and that's why you don't see a mother volume listed in the arguments of this function. So the order of the functions is first, remember this is rotation matrix. So in this case, we're not rotating, so we can just give it a 0 and it won't do any rotation. And then the next is G43 vector, so where we want it to be placed. And because this is the world volume, which every other volume must be contained in, then that's also why it's got no arguments entered in the G43 vectors, but we could also just rewrite this 0, 0, 0 to be explicit. And then we then give it the logical world to tell it what the solid volume name is. And then we give it a physical world as just the string name, which is the name that's printed out when we actually see the particle in it, as in when we do the tracking. So remember when we looked at the particle tracks, we saw the physical volume that the particle is placed in. So that's when this name here is used. And then we've got our mother volume here, and then this false. This is just the for the checking for overlaps and for copy ID and stuff like that. So if we just visualize this, and I'll just quick compile just because I changed that G43 vector to 0, 0, 0. So if we just run our simulation in interactive mode, then we can see what our geometry will look like at the moment. So you see we've got our world volume, and by default Geant4 will display volumes as white what do you call these things? Wire meshes by default, but we will change later volumes to solids, but by default, volumes are displayed as white wireframes. So you can see here we've got coordinates lined in our visualization. So we've got our YXZ, and you see these are 1 meters, and halfway between this is 0.5. So remember, we defined our volume to be 1 meter, and when we define it, we give it the half volume because the function is taking how far the distance is from the origin, and so that's why we always give it half volumes. So that's just a quick little getting our toes wet, but in the next video, I'll just show how to make another volume and add it to our current world volume.